welcome JCON. Thanks for being here. Thanks for coming to my talk, Moving Beyond Request Reply. And I want to look into basically how to integrate fine-grained components, microservices, and these kind of things today a little bit. And one of the main motivations actually for me to give this talk is one observation I also did, which is quite well expressed in that trends report, InfoQt 2019, and they basically look at different technologies and put them on these adoption lifecycle. Like if only innovators are looking in it, which really play with technologies, or early adopters, which kind of also take risks to be at the cutting edge, but also like early and late maturity, which are kind of the normal companies applying technology. And if you look at the hype cycle, microservices is kind of late maturity, which basically translated means everybody is doing it. And that probably relates very much to your everyday's life, I guess, at least. And what I find really interesting and funny at the same time, and true, is that they put correctly built distributed systems on the early adopters side. So what that basically means is everybody's doing microservices, but nobody can really do it well, because microservices are inherently a distributed system. And that's a huge problem. And I see so many projects struggling because of that exact problem in real life. So that motivated me actually to work on this talk I'm giving today. And a good way of capturing that is also like this picture. So if you do a couple of microservices, there's a mind shift you really have to do in your project and in your whole company, actually, is that parts of the system will always fail. And that's really an important mind shift. Like a couple of years back, there was like a lot of money basically put on the projects to make something highly available and always working. And we changed that assumption. It's too expensive. It's not possible in a largely distributed, big, complex system. But something will always be broken, or the network towards that component will be broken. And the important thing, and that's now the difference, is not to avoid that, but to deal with it in a way that it doesn't mean that the whole service, the whole system goes down in a way, right? So this is about resiliency. So the whole system should still work. Maybe a small function or part of a function is not working, but that doesn't affect the whole thing, okay? And that's a very important mind shift. And today I want to look at certain aspects of that, how to make that also happen technology-wise, what that means actually to implement that. And in order to tackle that, let's look at an example. And you probably remember the times when you used to travel. You probably also used airplanes. Like I did, actually, much too much in the past. And when you book a plane ticket, you book the plane ticket, and then you get an email invitation to check in normally 24 hours before your flight. And then you click on a link, and then you can select a seat and confirm a couple of things. And then you get your boarding pass, right? That's the typical procedure you see happening with flying. And I did that for a flight to London. I think it was 2018 for, I think, Yukon in London. And I booked a flight from Stuttgart to London. Everything worked, but then I wanted to send the boarding pass. And it basically told me, hey, there was an error sending you your boarding pass. And I don't know for Eurowings, but we have other customers doing very similar things. And I imagine it to be like this in the background. So I'm like communicating with a web user interface. That's probably communicating with the check-in microservice. And the check-in microservice doesn't do everything on its own, but it leverages other microservices in the background in order to do the work. Like, for example, generating the barcode which you have on the boarding pass. Okay, easy to imagine. And I imagine that some of these components didn't work. So the barcode generation, for example, they had some mechanisms in play. I'm not really looking into that today too much, but it's very important basic patterns available that you need in order to shield that error to really bringing down the whole system. Like, for example, a circuit breaker works like in your house. Something is weird with the electricity, it switches the electricity off before the house burns down. And the same thing is here is if something with the network connection is weird, probably it's responding very slow. Instead of all the threads exhausting in the check-in component, it basically just switches off and you get an exception immediately. Very important pattern. Not everybody has that. So and that it got a weird hobby of mine actually. So when I started doing that talk, I started to collect these error messages, especially from flight or let's say travel booking, from the travel booking realm. And now I'm it's kind of really weird situation. I'm always happy whenever something goes wrong, and I can collect another screenshot. This one from United, where they obviously had a really severe problem because something didn't work downstream. So that was not the case, but still they had a problem somewhere down the system, somewhere really downstairs. And what did they do? They basically bubbled up all the way up to me. So I saw that problem that the barcode cannot be generated, or I basically saw I can't get it like a boarding pass, which I want to have. And I don't think, and now the question is like, what can I do about that? What can I do about this situation? And I think it's very obvious. I mean, we're computer scientists, so what you normally do is you turn it off and on again, so you retry it, right? Of course, I pressed F5. It didn't work. I waited a minute, tried it again, it didn't work. The next thing I did is I said, okay, I tried again in a couple of hours. And therefore, I created an entry in my Outlook to not forget about it. And that's what I call a stateful retry. So I did this retry, but later. So it gets kind of a long running task. It takes 4 hours. And in order not to forget about it, I need to store it somewhere persistently. We'll come back to that in a second. Okay, so I did that. The fun part of that story, and it's really true, it's the same trip. My onward flight from London was EasyJet. And the same problem. I wanted to get a boarding pass, and they said, okay, we're sorry, we're having some technical difficulties at the moment, but they know they're better. They give you the work instruction. Please log on again, retry. If that doesn't work, please try again in 5 minutes, so increase the interval. And then I love that part most. We do actively monitor our site. We will be working to resolve the issue. There's no need to call. It's your problem. Please solve it yourself, right? And that's a weird behavior towards your customer. I mean, and the customer could be a service. I mean, another microservice. I'm thinking about always the customer is somebody using your service. It might be the end customer paying for the flight, but it could also be the check-in component if you're the barcode generator. So that's a bad behavior towards your customer. It should be, hey, we're having technical difficulties. We're sorry, but we're solving that. It's our problem. We're solving that. And don't worry, we send you the boarding pass right away. Whenever we're ready, you don't have to worry about it. Right? That would be much, much better, right? And that means you solve it, in this case, in the check-in component. And that should do the stateful retry, because then, like on the user side, you don't even have to see it, right? The problem. So I think that pattern is a pretty important one, actually. The problem I'm seeing projects having with that, it's like, oh, stateful. That means the check-in now gets long running, because if the barcode generation doesn't work for minutes or hours, I need to store that state, need to remember that I still want to generate that barcode. And how do I implement that? I need a database, I need a schedule, I need this and that. And that's actually not true. It's much easier to implement that you think. And that at this point, I always give the warning, I'm a human being, I'm opinionated, of course, like everybody. I just want to make it transparent. So my name is Bernd Rücker. I'm co-founder and chief technologist of Camunda. We're an open source process automation technology vendor. So that's my opinionation in a way. But I mean, I worked with workflow engines over the last 15 years, basically. I contributed to a couple of open source engines during that time. So I'm looking at problems through the lens of workflow engines. Okay, that's important to know here. I'm currently writing a book with O'Reilly, Practical Process Automation. The Zoom stuff is on top of the title. That shouldn't be the case. And I'm searching for tech reviews. So if you fancy that, shoot me an email. Happy to share the draft with you. There's my email address. Also, if you have questions after the talk, you can tweet me. You can tweet about the talk if you like it. So all the contact data there. So that's me, and that's my opinionation. So let's go back to the talk. If you use process automation technology, workflow engine, you can express workflows in these kind of process models. That's BPMN. Don't talk about that today. But I can express it somewhere. It starts, then it generates the barcode. The next thing it does, it sends the barcode via email, for example, and then it's done. That's a very simple process, but I can already execute on the workflow engine, and that persists the state. So it can wait in the generate barcode for hours until the barcode generation becomes available, and can do the retry and can do the escalation. Hey, we're waiting for too long. We have to do something else, and so on and so forth. Okay. I know that's a very simple process, but it already leverages capabilities of the workflow engine, which are very, very valuable here. If you want to see code, I don't have time today to dive into the code. There's a GitHub repo on my GitHub account. Also happy to share the link later on in chat, where you can find the exact sample I'm doing today in code. In this case, it's mostly Java, but I also have a bit, I mean, oh, we're at JCON, so Java is fine. I also have other languages, but mostly Java Spring Boot. You should be able to run it yourself because it's very simple code. That's what it actually shows. But today I want to talk or focus on the whole interaction of that request response thing. So one important thing here is if you do this retrying or stateful retrying, on the client side, you have to think about something called idempotency on the service provider side, because retrying means you basically call the same method probably a couple of times because the retry kicks in, and the service provider should be able to handle that. And let's make an example again where this is not really done in a very nice way for the user from travel booking industry. So in this case, when you book that flight here and you know these loading wheels, right? You basically enter a credit card detail, push a button, and then you get that, hey, your transaction is in progress. It may take up to 60 seconds to complete. Please do not close this window or select the back button on your browser. That's the moment where always some evil part of my brain thinks like, hit the back button, close the browser. But I never do that because I mean, I paid for the ticket. I want to have the ticket actually. So, but it's a bad design towards your client. It should be something like, hey, you want to give us money? Awesome. Don't worry, we will make that happen, man. You can close the browser as often as you want. You can hit F5 every milliseconds. We don't care, right? So that's the behavior that should work here. And because I find that so important, I made up an own metaphor for that, because I think metaphors help very much to remember things. I know it's a very silly metaphor. I explain it in a second, but if you know any better one, happy to take recommendations. Just reach out to me. So, right, you guessed right, that's a zucchini. So what's the story about the zucchini? A couple of years back, I ate vegan, and my favorite dish was this. You do zucchini noodles. So you have a special slicer. You put the zucchini through the slicer, and then you get noodles out of the zucchini. You add some sauce. Very delicious. Awesome. I can totally recommend that dish. The good thing about that is as well that you can eat as much as you want to. Even in the cookbook, it says you can eat it in the evening and you can eat as much as you want to. You don't grow fat. It's not unhealthy, so eat as much as you want. So since then, I started using that as a metaphor for idempotency, because if you eat your dish of zucchini, one plate, and then you're done, and then you forgot, did I already eat something? So you can eat another one, and then you forget again. I simply eat another one, right? And another one, and it's totally idempotent to eat zucchini noodles, and this is very different with pasta, right? I know it's the best I came up with so far. So happy to take recommendations. For me, the important thing is that it sticks, and that idempotency is super important. I think it's if that's kind of new to you, idempotency, I think it's one of the most important messages here in the talk. Idempotency is super, super important. And to make an example, let's say you also pay for the flight you're booking, then there might be a payment microservice, and that might leverage some credit card microservice, or probably even a cloud service for charging credit cards, right? In that situation, when you design the API between payment and credit card charging, you could do something like simply, hey, charge the credit card. Here's the card number and security number and the amount. But that's not idempotent. If you do the same charge again, you have no idea to recognize that's the same call. You could say, oh, there's the same charge on the same card issued by the same company within seconds. That's very likely to be a duplicate, but it's guessing. It's best effort. You can never know. By simply adding kind of a transaction ID, which the client generates, you make it idempotent, because now you can retry it, and the credit card service, if it's already seen that request, knows, oh, that transaction ID I already know, it's a duplicate. Okay. And the trick is really to generate these IDs as soon as possible. So even if you, for example, place an order or place a ticket booking, you generate the ID already in the client, in the browser, for example, a UUID, and then you can like put it in the whole chain towards whatever service you have, and then you can recognize these duplicates. That's so important to do this right. Idempotency. But that's not it. If we stick with the payment and credit card service, and let's assume you do the retrying, let's assume you do idempotency correctly, so you did a lot of things right. But still then, after some time, you might give up. No retries left, so the payment fails. Right? That's the typical situation you normally do. At some point in time, you give up. It doesn't make any sense anymore. And then you raise a payment failed error. Now, one really ugly characteristic of distributed systems is that it's really well explained by that metaphor, which I like for distributed systems. So this small hut over there, that's your one microservice or whatever you do, your one application, one programming language on one, let's say, container, one JVM, transaction management. A lot of nice things are happening. Within this small hut, you have, like, it's cozy, right? But whenever you open the door, then you have that rough ocean, and that's the network. The network will do really weird things. It will lose some bits, turn bits around, and whatever it does. So that's the bad situation you will face when you enter a distributed system. And just to make one example, you have you're a client and want to talk to the credit card service, for example. Now you get a network exception. The interesting thing here is you have no idea what just happened. It might be that you never reached the service provider because the network was faulty. But it could have been that you reached the service provider and it exploded while it basically processed your request. Now, it could be that it committed its transaction or not, you have no idea. Or it processed everything correctly and the response got lost in the network. All of these scenarios could happen with the same network exception on the client side. So you have no idea what happened. You cannot know. There's no way of knowing. And this is something you have to deal with. You have to think about. So in this situation, like payment has failed, you really have to think about, what does that mean? I might have charged the credit card, okay? And customers might not be so relaxed about charging credit cards and then not booking the ticket because the payment has failed. So you need to kind of clean up. You have to go back to a consistent state. In this case, it depends on the API of the credit card service. You cancel the charge, you check if something was charged and then cancel it or whatever. The important thing is you have to do it. And again, you have to do it reliably. So if the credit card service was not available when you try to charge it, chances are high it's not available when you try to cancel things or clean it up. Okay? So that's really important here. And that also might mean to be long running because I might need to wait for the credit card service to become available again. Okay. So that's what I'm trying to get at. You need to be able to implement long running services. In this case, I solve very technical problems like the REST API might not be available, right? Or I don't have technical transactions at play and so on and so forth. When I say long running, and that's kind of probably not the only way of doing it, but at least in my biased brain, the best way of doing that means leveraging a workflow engine which can persist state and wait for things, retry things, escalate things, and so on and so forth. Okay. Let's extend that example a little bit. Let's say you have the payment at the booking service. And the booking says, hey, retrieve payment from me. The payment service now charges to the credit card. So far, we know everything, right? And now let's say the credit card service is available, but it returns a business error, like credit card was rejected, expired, locked, whatever it is. Now the payment service has to deal with that. And let's say the easiest thing what it could do is it could basically sorry, that was the wrong direction. Could simply pass on that error towards the booking, says, hey, credit card rejected. We can't do things. Okay. Now let's assume you get a requirement like this. Hey, if the credit card is rejected, please send the customer an email and ask for updating his credit card. I mean, he wants to do a booking. We keep the seat and we keep everything reserved for him for 4 hours, right? And if he provides the credit card details within that time, we simply charge and we're good. That's a much better customer experience. You probably sell more tickets and so on and so forth. So that's a very valid requirement. And if we think about that, the next thing we have to think about is where to implement it. And if you have this design, and I see that actually very often happening, you're tempted to do that in the booking, right? Because booking gets a credit card rejected. Booking normally has kind of long-running capabilities, so it has some state stored somewhere, so it can relatively easily handle that. But I find that a very bad design, actually, decision here, because it's not the responsibility of booking of caring about credit cards. If you think about microservices, it's all about putting responsibilities into the right microservice, make the right team responsible for these requirements. And otherwise, you end up with something like Sam Newman calls that God services in his book, in his microservices book. They had a few smart God services, tell anemic CRUD services what to do. And this is if you do this. This happens if you pushes that towards booking. That's not what you should do. You should really think about who is or which service is responsible or which team is responsible for that requirement. And that's obviously the payment service, right? And that should handle that and then like respond to booking with a, we have received the payment or the payment has failed, but then it has failed. We can't do anything about that, right? The interesting part is this makes the service also long running. For me, again, long running means it can probably take like days or hours to wait for the customer to update his credit card, but probably even days depending on the use case. And one observation is that in this microservices world or in distributed systems, that most services actually are at least potentially long running, because you always have at least like technical requirements, a REST call where you might need for the service to become available, or like in this case, a business requirement, which should be in the microservice where you need to wait for things. Right? Okay, so you need to be able to implement these long-running services to solve business requirements too, not only technical stuff, but business requirements. And you can leverage the same capability like a virtual engine. I'm not getting tired of mentioning that for this requirement. Let's switch gears a little bit. So if we say, okay, we want to do service long running, we implement them long running, or we make services long running, you require asynchronous communication, right? Because you can't keep a synchronous request open for days. That simply doesn't work, doesn't make any sense, right? My favorite quote about synchronous, and then a lot of people have problems with that. And my favorite quote here is, synchronous communication as a crystal meth of distributed programming. And Todd Montgomery and Monty Thompson said that quite a while back, actually, at the Go to Chicago, but I love that quote. And it's a bit like, a lot of projects know that they should go asynchronous nowadays, that it's kind of has a lot of advantages. But like synchronous sounds so easy, like a REST call, and I simply wait for the response and can move on. But what if it fails? Yeah, but I know I should do different, but let's do that tomorrow. I want to keep it easy for today for that project, just the last time, and then I quit, right? So that's important to keep in mind. So I actually like asynchronous communication very much. Another interesting thing here is that it doesn't change the whole game. I mean, if you have long-running requirements, long-running capabilities already built in, you can easily leverage these asynchronous components. Like you could also send a message to the barcode generator and wait for the response. Now you can have the same failure patterns. Maybe you never get a response, and you don't want to have the user in front of the computer recognize, hey, they never sent me the promised boarding pass, I have to resubmit. but you want to have that within the check-in component. So you need to monitor that. That's again where workflow engine comes in really handy. So you could send out the, hey, generate a barcode, and then you wait for it. And now it can easily also, it's persistent, you can wait for a long time, and it's easy to handle time, like to escalate or to retry or whatever you need to do. Or you could even say like, okay, we try that as hard as possible, but if it's not working 4 hours before the flight, we do plan B, like sending a text message, we don't get it working, please go to the counter. That worked. I even got that from, I think it was Virgin Atlantic once. They didn't get it to work. I got a text message on my mobile phone, approach the counter. Not nice, but it works. It's fine. And the workflow engine enables that because you can like wait for things, schedule stuff, and so on and so forth. Okay, nice. So that's the other side of the medal. So if you're getting long running, you need async, but also being able to implement long running makes it easy to get async. And for me, that all goes hand in hand, like distributed systems, the problems you have to solve need long running capabilities, not long running kind of makes it async. Async means you have to have long running capabilities and so on and so forth. Okay, that's kind of, that gave the target's name, moving beyond a simple synchronous response. Okay. If we are talking about async, another thing that's kind of very often woven into that whole topic is the reactive movement. And you probably know the reactive manifesto. Did I link it? No, I skipped it. The reactive manifesto basically says we want to get a more reactive application that's basically built upon a more resilient application and a more scalable application. And both of these characteristics can be reached by getting asynchronous communication messaging. Let's do an example again. And let's switch examples for now. So instead of doing travel booking, I'm doing order fulfillment. And I'm using the Amazon Dash button as an example here. Amazon Dash works like this. You put the button right next to your, for example, washing powder. You press it once when the washing powder gets empty, and then one box of washing powder gets shipped to you. Okay, that's Amazon Dash. In the background, it's a normal order fulfillment process. If you implement that with microservices, you might end up with these microservices like checkout, which communicates with a button, payment, which retrieves money, inventory, which cares about what's on stock, and shipment for creating all the parcels or the like IDs on the parcels. What does it mean? What does reactive mean? Very often that's connected to an event-driven way of doing applications or systems. Event-driven could mean that all these like microservices emit events, probably on a central event bus, like, hey, somebody placed an order, hey, we received payment, hey, goods were shipped. Okay, these are domain events. They transport domain information that something just happened. What that enables is that you can now build other components, for example, a notification microservice, subscribing to these events and basically sending, for example, emails to the customers like, hey, we got your order, we received your payment, and so on and so forth. The great thing about that is you don't have to push that requirement. You don't have to implement that in the other services. Like you don't have to think about like when to send emails again in the payment microservice or how to send emails, but you really have that encapsulated in like one service, the notification service. Okay. That's great. And that's the advantage of event-driven communication. Now, what you could also do now is you could use these event notifications to implement the business process of order fulfillment. Because you could say like, checkout emits or somebody placed an order event. So payment could react to that and saying, okay, then I retrieve payment. Emit another event that everything is fine. So inventory subscribes to that saying, okay, when the payment was received, I get the stuff from the stock and so on and so forth. So this chain of events implements the business process on the right-hand side. My problem with that kind of design is that you lose sight of the basically of the the business process, it's pretty hard to understand how the process is implemented. You either have to look at all the different microservices, like different code bases normally, and check where or to which events they subscribe to, or you somehow observe the runtime behavior of what's happening here. And both is actually not trivial, totally not trivial. So it's really hard to understand what's going on here. And you see more and more reports of problems of this approach, actually. So this one is from Phil Calzado at QCon New York last year. He talked about what they do at Meetup, and he said we were suffering from pinball machine architecture. That's the metaphor he used for that kind of architecture. And it's pretty easy to imagine, like, okay, you send in like the first event, and then it bounces through the system, hitting a couple of other microservices, and somehow you have no idea what just happened. I love that animation. I just have to do it. And this is kind of, you normally recognize that by situations people ask, like, how did that happen? I mean, we never implemented that case, that our system can't do that, can't happen. And it's really hard to understand these kind of systems in a way. And I see that as a big risk, actually, with the whole trend towards event-driven architecture and these kind of systems. Okay. You can easily show problems with that approach whenever you need to adjust things. So probably to add one thought here, my personal hypothesis is that so far what I saw at most companies happening is that in the beginning it looks easy, because whenever you simply add services, you add the payment service, it can react to an event which is already there. You don't have to talk to the checkout team. Great, I can just add something. So adding is easy. But as soon as you start changing things, understanding and changing things, like for example, hey, I want to fetch the goods from stock before I wait for payment because I need same-day delivery, I need to be faster. If you do this, it gets really hard. Because in this example, you have to, payment no longer listens to order placed, but to goods fetched. Right? Eventually no longer listens to payment received, but order placed, and goods shipped. No longer, you get the idea. So this is the visualization of that. So you have to adjust the 3 microservices on the bottom part of the slide, actually. And that's totally not the idea of microservices, right? Because now you have to coordinate the changes of these 3 microservices, and you have to coordinate the redeployment of them. Because if you have an order circulating through these services, you need to know if it's paid or not in inventory. So that's also a versioning problem, a distributed one. And that's really hard actually to solve. And I see so many companies currently struggling with that. That's also called a choreography, this event-driven communication and this event chain you just saw. And one problem I'm currently seeing there is that it's kind of advertised in a lot of talks, actually, with this metaphor of a dance. It's a beautiful dance. The dancers know the rules. They know the choreography. So you can simply add another dancer and it will be beautiful. And it's not exactly what I see happening in real life. Okay, it's very often pretty chaotic, pretty hard to manage, pretty hard to understand. And that's a risk you should be aware of when you enter the realm of these choreography. Okay. The alternative to a choreography is an orchestration. And it looks like this. And the first thought, and I find that already very important, is in this case, this chain of events, this order fulfillment business process. Somebody needs to be responsible for that. It's not emerging out of the air, emerging out of a couple of reactions. That's pretty naive, actually, to think about companies like whatever Zalando or Amazon who live from order fulfillment, that they let it emerge. So you need that capability somewhere, and that could be an order fulfillment microservice. And that not only needs to react to certain things like an event or the place, but it also needs to coordinate others, like command them, hey, payment, now retrieve the payment for me. And then it waits for payment to happen. And then it says, okay, no inventory, no shipment. So you coordinate certain things with the architecture. And that's a lot about responsibility. Is the payment service team responsible for handling the payment at the right time? Or is that an order fulfillment team? Like, who's your CEO approaching if you ship orders that are not paid? That's an important question here to ask. That's about events and commands. Events are something that happened, and a command is you want something to happen. And for me, that's, by the way, I'm getting probably, that gets very, very much into the details, into the weeds. But for me, that's choreography is about event-driven communication and orchestration about command-driven communication. Okay. It's not about technology. That's an important message here. It can still be messaging. A lot of people think when I say orchestration, now it's REST again, synchronous. You said we shouldn't do that in the beginning. No, I'm not saying it's REST. It can be messaging. It can be, you can put a command on Kafka. It's totally fine. And again, because you have distributed systems or probably async or event-driven and so on and so forth, you need to have that long running in a way. And that might require like long-running orchestration. Looking at how to implement that with a workflow engine could mean something like, okay, I send a command to retrieve the payment, wait for it to happen, then I do the next thing, and so on and so forth. And that's domain logic. That's logic that sits in the order fulfillment service. And probably other services have long-running behavior as well, as we already discussed with the payment earlier on. And so most of the microservices might have long-running behaviors inside of them. That's another important thought, because when I say workflow engine, a lot of people think of centralized things. It doesn't have to mean that. Okay, so let's do a quick recap. So distributed systems are complex. That's something you should really be aware of, right? You have to think about retries, stateful retries, idempotency, super important. Think about the zucchini, don't forget that. Embrace asynchronous. I think asynchronous and long running are characteristics that are easier to handle in these scenarios, but make sure you be able to handle that. It's not an easy endeavor. You need to be able to implement long running services. Workflow engines might help. That's not the only way, but I find it a very, very easy to understand way, but happy to discuss. And then even if you're async, it doesn't mean you have to go into the event-driven choreography model. Event-driven choreographies are great for some problems, but orchestration is needed for others. I always think of it like I have commands and events, and I need to balance the use of both in my architecture. I can never have an architecture that's only orchestration or only choreography. I always need to balance both styles in a way. If you want to learn more, I said that earlier on, that's the ad block of the talk. I'm currently writing that book. It's an early access, so you can already read some of the chapters. If you want to do a tech review, reach out to me. I hope you found that kind of interesting. Thank you very much. There are some links, and I think that gives us some time to look into the questions. Let me check my screen here for questions. Where is this? Okay, don't see any questions so far. I try to hurry quite a bit to make questions reality. I give you a minute to think about questions.
I could try and ask a question.
Okay.
In your examples, so microservices, those services that you presented, they, so your suggestions are like to make them smarter. And by this, you also make them bigger or thicker. And maybe they should have then to start having their own storage somewhere or something else. And with redundancy, if there are a couple of hosts which are doing the same microservice, they will be, how to say, this the storage will become also more important. I mean, it sounds to me like they are stop being microservices. They're getting bigger. I mean, what I'm thinking wrong here?
Yeah. So just to repeat the question and double checking that I don't get it wrong. So you basically said, okay, I'm saying we need these, for example, long-running behavior in most of our microservices to solve certain problems. And that means we need state or store some state in most of the microservices. That means we need more environment for them, and that makes them bigger, more complex to do. Isn't that moving away from the idea of having lean, small microservices? And that's a very good question, actually. But my thought around that is I have some capabilities I need in the environment in order to implement microservices. So one would be like, for example, I need a container infrastructure, maybe I need networking. I need a couple of things in order to run a microservice. And if I define that stack, then if I have that somewhere organized how these capabilities are done, it doesn't make the code for my microservice bigger. It doesn't make the development of the microservice harder. So if I add some long-running behavior into that mix, it's not necessarily a more complex microservice. I even think the other way around. Then you're able to make easier microservices because you, and I like this example. It's a very small one actually, but I see that happening very often, that you push certain certain requirements to other services simply because this microservice don't implement state. And that makes it harder to understand architecture. So I would go for something where the environment provides you with the right state handling, and then you can implement it at the right place. And if you look, for example, at more, it could be serverless, could be more cloud-based environments, it's not so hard to get the right capabilities. It doesn't mean that you have to operate your own database. It doesn't mean that you have to operate your own workflow engine. You can get that as kind of a service. And maybe it's simply a deployment descriptor somewhere that you want to have the capability enabled. And if you're at that point, then you can implement the requirements at the right place. And then it gets leaner again, even if the microservice is doing a bit more. Does that make sense?
Yeah.
Oh, okay.
Yeah, thank you very much.
There were one or two questions in the chat. So could all of this be done with Java EE? I'm kind of surprised by the question around Java Enterprise in 2020, but yes, of course, why not? I mean, independent of what you program, if you, for example, connect to something like a workflow engine, and I didn't go into details of our product or any product or code, but if you look at, where is it? Somewhere I had this code slide, right? If you look at the, sorry, PowerPoint is here. So if you look at that example, what you will see is that I embed the workflow engine via Spring Boot Starter into my Spring code. That's a very easy approach, but if you look at our engine, for example, you could also run it even as a container service in a Java Enterprise container if you still use one. So there are a lot of options. It doesn't stop. I mean, you could use any language, so also, of course, Java Enterprise. What about stream reactive models? Is that even a newer communication pattern, or is that just an event stream? That's also a pretty good question, actually. I thought about streaming for quite a while. And for me, that's different things. So the one thing is, I mean, events are kind of streams typically, yes. So if I look at the example I did with order fulfillment, I could have streams of events, and then I could implement that by means of event streaming. And then I have exactly the same problem. So for me, event streaming and choreography goes very close together. There is probably one difference sometimes if you look at streams in the sense of pipelines, where I really, for example, really load data from A to B, and I just have a pipeline going through a couple of transformations. That's normally a bit of a different beast than implementing this kind of business process like this. Okay, so there are differences, and there are also interesting combinations. So I'm not sure if I find that quickly enough. Not sure if it was in this blog post. Still need to write a blog post actually about that. But we had a use case also in aviation, where, yeah, exactly. This one, as soon as the picture loads, we should be able to see it, where we combine data streams, for example, from a airplane generating a lot of sensor data, and this sensor data is going through a couple of processing steps, like, I mean, oil pressure of whatever is that, what does that mean? And then you generate insights of that's a critical oil pressure. And that's all done by data streams, where you stream in data, act on it, and produce new data. But then at some point in time, you look at that data and say, okay, there's a critical measure. We need to act. We need to do something. And then you kick off a real process instance, because then you really have to care about that. And I have no idea why the picture is not loading. But then you can dive into that a little bit more. So it's kind of a interesting connection here, also possible. So data streams are not a totally easy answer here. So every technology has its playing field in a way. What are different players in the workflow automation scene? You mentioned Camunda, which looks interesting. Are there others that work well for building microservices? Let me first back up the first part. Camunda is interesting, definitely. So yeah, there are a couple of vendors, and if you look at the workflow automation space, there are even a couple of categories which are interesting to look at. And I once made this slide. It's a bit old, to be honest, but I think it still captures my thoughts very well. So there are a couple of different categories, if you will. So they're pure play BPMS. So these are kind of the BPM tools from, as I call them, from the past. They're very often connected to low code. You click together stuff and you don't need any coding. And these are normally the big vendors. Try to stay away from them. That's a very easy recommendation. There are some, I call them homegrown frameworks to scratch an itch. So for example, Uber did some framework to have a workflow engine in their Uber stack internally, or Netflix, right? And there are frameworks that are really built for that internal purpose, and now also put on GitHub open source, right? Then there are cloud offerings like, I think I have some names on here, right? Like on AWS, they can do something like step functions as a durable functions, right? These are kind of workflow engines, very limited actually in what they can do, but workflow engines. There are integration frameworks like Apache Camel or such, which normally lack the persistence, the storage aspect of it, but also very often are put in the same melting pots, or pipelining. That was the question from before, like Apache Airflow, Spring Data Flow, different problem to solve in a way. And then there are like a couple of open source workflow engines. There, I would say Camunda, I find obviously the most interesting, but you can evaluate it yourself. I'm not worried that you end up with something else. JBoss has JBPM. I have a history with that as well. Activity has kind of the same roots as we. There are a couple of others. For me, I mean, it will always be biased. I know why I think Camunda is kind of the best, but you definitely have to evaluate that yourself. But the important thing is, don't end up here because you don't have persistence. I think these are pretty limited. I mean, we also have a cloud offering. I have a couple of ideas why this is much better, and I would keep away from them and probably be very, very cautious here, because you don't have any guarantee on what's happening in the future. Nice. Let's see, probably one last question. In the event-driven architecture, if I'm interested to wait for one process to be finished, even though it's asynchronous, how this is implemented? Just let the user keep reloading the page. Yeah, in a way. So because of time constraints, I actually skipped a bit of the whole storyline, but where could we best explain that? So what I normally see happening, don't want to go through the whole example, don't have the time. Let's make the example here where I could say I book the ticket. Where was it? I booked the ticket. PowerPoint is really behaving weird today. I book the ticket here. And let's say you do it in the right way. Like payment can take for ages, but you want to have in the booking, you want to have a result immediately. What you normally do is you have some kind of synchronous facade here, where you implement something like, hey, I retrieve the payment and then I wait for a response for, let's say, 1 minute max, or no, 1 minute is too long, 30 seconds max or 20 seconds max. And if you don't get a response within that time frame, you basically tell the user, hey, we send you a response later on. And then normally you have a different channel back to the user. It could be an email, it could be pushing something to his account. Depends a bit on what technology you have there, what kind of communication you have towards the user. But it might be that the user refreshes his page himself. So if you, for example, apply for ESTA in the US, you get a number, right? And you have to go back to the web page, enter that number, and query for your status yourself. They don't push any information to you. So all of that is viable. You just have to think about the user journey you want to get at, okay? And the important thing here is you can have a synchronous response in the happy case. Everything is working smoothly and fast, and then you get a synchronous response. That's okay. And if that makes a good user experience, do that. And we even support that in the workflow engine. For example, we can wait for things to finish and then return a response. But you always have to plan for the timeout. It's not happening because something is not working. Okay, that's for me very important to keep in mind. So I think we're at the end of the time box. I think we have to make room for next speaker, otherwise he might get nervous. Happy that you joined the talk. I hope that helped some of you a bit further. As I said early on, if you have any questions, feel free to reach out to me on Twitter, via email. I will make sure to post the link I just had on the slide early on in chat now, so you can copy and paste it if you like. And hope to see you back some other time soon. Enjoy the rest of QCon. See you around.